Already you know that arene means aromatic compounds, correct? And well-known aromatic compound is nothing but what? Benzene, right? So how you can prepare the haloarenes? From hydrocarbon by the electrophilic substitution, right? Because, but then one question would be there in your mind. If you see the benzene ring, if you see the benzene, it is electron rich, correct? Yes. And if you see the halogen, it is also what? Electronegative, right? So how electrophilic substitution is possible in this? That this question must be arise in your mind, correct? Yes or no? What do you mean by electrophile? Tell me the meaning of electrophile first. Any one of you, Aditi, Chandana. Hello.
And like the species that donate or accept electrons to form a new bond.
Electrophilic, the molecules are the ones which are electron loving. They lack electrons, so try to gain electrons, and they're positive in nature.
Electrophile are electron deficients. Okay. Electron deficient in nature. Okay. So they always have a positive charge on it. Right? And when it come in contact with the electron rich species like a benzene, so benzene can attract towards them and form a bond. And such a bond is called as electrophilic bond, and such a substitution is called as the electrophilic substitution. Right? And opposite is nothing but opposite species of the electrophile is a nucleophile. Right? And that substitution, when nucleophile get attached to the benzene, or nucleophiles get attached to any of the another haloalkane or the haloarene group, that would be the nucleophilic substitution. Correct. So nucleophile would be electron rich. And this electron rich, how we have to attach with the benzene, because benzene is already electron rich, right? What we know, oppositely charged attract each other. But then similar charge would repel each other, right? This rule is there in your physics. It is there in your chemistry. Even in the real life also, we see this rule, correct? Yes or no? Opposite attracts. So for that, we have to make this halogen electron deficient. What we have to do? We have to make it electron deficient. And to make it electron deficient, we have to use catalyst, right? And which catalyst we are going to use? That is Lewis acid or Lewis catalyst. It is called as Lewis acid or Lewis catalyst. Okay? Understood? Hello? Yes. Fine. So what you come to know, basically, we are going to see the electrophilic substitution. What do you mean by the electrophilic substitution? Means the electropositive species we are going to attach to the benzene. Correct. But then what we have to do, we have to make a haloarene. Means your electrophilic substitution should be of halogen group. What we know, halogen is electronegative in nature. And as we are going for electrophilic substitution, we have to make it electron deficient. And for that reason, we are going to use a catalyst, and that catalyst is called as a Lewis acid. Correct? Clear? Hello?
Yes, ma'am.
Fine. I'm going to clear the screen now. I hope whatever important facts you have written on your notebook. See, in this case, what happened? Here would be a benzene ring. I'm going to draw. Right? And here is the CH3 group. Which compound it would be? Toluene. What it is?
It is toluene.
Toluene. Fine. So when it come in contact with a halogen, in the presence of Lewis acid, this Lewis acid would be FeX compound, FeX2, FeX3 compound. It depends on the ion valency. If it is 2, then it would be FeCl2 or FeBr2. If it is +3, then it would be FeX3. Understanding? It can be either FeCl3 or FeBr3. Correct? And this is called as what? Lewis acid. Okay. What is role of this? It will take one halogen out of it, right? And it attract the electron towards this catalyst, and hence another halogen would become an electron deficient. Correct? This is the role. Means in mechanism, if we see what we will get, suppose this is the benzene, fine, benzene ring, which substituted by CH3 means it's a toluene, right? What happened within this two? X, this is X2. It gets bonded with what this FeX3, and hence it will be converted into X attached with FeX4. Okay, fine. So it become electron rich and it become electron deficient. Okay, and this electron deficient species would be attacked by either ortho position or either para position of the toluene. Okay, this is a substituent on the benzene. The next to the substituent is called as what? Ortho position, and one-fourth position is called as what? Para position. Correct? And these two position would be electron rich, and this electron rich and electron deficient position would be depending upon the substituent present onto the benzene that you might have learned into in grade 11. Correct? Yes or no? Have you learned it or not? Otherwise, I'll explain you.
Yes, ma'am.
Yes, ma'am.
You have learned, right? So CH3, it's the electron, it has the electron donation inductive effect, right? So it makes its ortho position electron rich and its para position electron rich. So what happened? One by one, this either ortho position would be attacked on this electron deficient species, FeX4 would be depart, right? Or else para position would be attacked onto the X and your FeX4 would be detached. And you will get the two product. Among that, first one would be ortho halo. This is suppose your CH3 group. Its ortho position, ortho halotoluene, and product would be what? Your para halotoluene. This is CH3, and here it is X. Correct? So what it is? Ortho halotoluene. And this would be what? Para halotoluene. Clear? Yes or no?
Yes, ma'am.
Yeah. I'll explain you this mechanism as well, like how this formed. It's not given in your textbook. Please write down this. Once you have done, let me know so I can erase it. Because you're not giving me feedback, like writing is there, or all student gives me, actually I take rest all classes. I'm not getting any sort of writing from the side. You're too busy for that word. Hello.
Yeah, ma'am, can I repeat? Like, there's the power cut over my place.
Ma'am, but your
You
voice,
don't know how to do it? Sorry?
your voice is breaking
Hello.
slightly.
Okay, but then now still it is breaking?
Now it's fine.
Okay, fine. Once it is done, let me know so I can erase it. Shall I erase?
Yeah, ma'am, I'm done.
Okay, fine. Actually, I just wanted to erase a part so I can explain you the further mechanism, what exactly happened over here. Fine. So You come to know what exactly in this case? Ortho position if get attached with this electron deficient species. Suppose this could be your benzene ring. This is a CH3 group, right? And at the ortho position, X has been there. And it is attached with the hydrogen as well. But then how it will be get attached? In that way, this double bond would be gone because that double bond is utilized to form the bond with halogen, correct? Yes or no?
Yes, ma'am.
And as it is gone, it become electron. This position would become electron deficient, right? Yeah. And to make it electron rich again, this hydrogen would be lost and you will get ortho haloarene. And same thing would be happen with your para product as well. Suppose this would be your benzene ring, right? This is your substituted CH3 group, so it becomes toluene. If here would be your X attached to your FeCl, or sorry, FeX4, right? What happened? This bond would be utilized to form a bond with this. What you will get? Para substituted halogen. Here is the hydrogen. Here is your X group, right? This bond would be here in this case. And here would be your CH3, right? And it become electron deficient. To make it electron rich again, this hydrogen would get lost, minus H plus. You will get what? Your para substituted product. Fine. Ortho meta. Sorry, I have kept it here. It should not be here. It should be at the para. You should tell me. I was expecting this from you. Yeah? Isn't it?
Yes, ma'am.
Yeah, ma'am.
Not a para position. If it would be here. Yeah. So if it gets attacked, your hydrogen would become here in this case. Right? X, H. After losing this, it become electrodeficient. This writing pad is not working properly. It will be in this manner now. It become positive. So what happened? It will forcibly form this. You will get this product. CH3 1 4 1 2 3 4. Para haloarenes. The same mechanism would be happen. Just instead of ortho position, it takes place at the para position. Clear? Hello.
Yes, ma'am.
Yes, ma'am.
Shall I erase it now?
Ma'am, 1 minute. Done, ma'am.
Okay. Now, this is all about what? The bromine and chlorine. But then if you have to react this electrophilic substitution you wanted to conduct for the iodine, so it is quite difficult because this reaction would be reversible reaction. Keep it in your mind. With iodine, right? This electrophilic substitution is reversible reaction, right? And as it is reversible reaction, what happened? We have to use an oxidizing agent. What are the oxidizing agent? HNO3 and HiO4. These two oxidizing agent we should use. What are these? Oxidizing agent. Okay, to get haloiodide product. Sorry, not iodoarene products. Fine. Then apart from that, fluorine we are not able to substitute by the electrophilic substitution because fluorine is highly reactive and it is more electronegative and it cannot be converted into electrodeficient species. Understanding? Already in the periodic table you might have learned highly electronegative species are what? Highly electronegative element in the periodic table. Which one? Yeah, it would be fluorine. Correct? So it is very difficult to convert it into electron deficient species because it is already electronegative. We cannot convert it into electron deficient species. And second, it is highly reactive. Highly reactive in nature. Fine? Yes or no?
Yes, ma'am.
Fine. I hope I have cleared about all the 4 halogens. We have learned about what? Fluorine, chlorine, bromine, and iodine. Among that, fluorine and bromine can undergo electrophilic substitution. Right? Fluorine can't, and iodine can by using oxidizing agent. And which oxidizing agent? HNO3 and
HNO3 or HiO4.
Clear?
Yes, ma'am.
Shall I erase it now?
Just a minute, I'm just writing the last part.
Fine. Once you have done, let me know because the next reaction which we are going to learn that would be a Sandmeier's reaction. I'll tell you student till the time you are writing this Sandmeyer reaction practically I have performed in my master's project. When you take a master degree in your chemistry, that time in the final year you have to perform one project. Practically you have to make a few drugs. Among that, one of the drugs which I have prepared that was the tribromoamine was there. And in that, I have followed this reaction practically, Sandmeier's reaction. Diazo coupling. You will come to know what it is. And I think in last period only I told you about the sulfo and azo. Sulfonic group means what? Sorry, thiolic. Thionic group means what? Sulfur. And azonic group means what? Nitrogen. Correct? Nitrogen compound is called as azo compound and sulfur compound is called as thio compound. Correct?
Yeah, ma'am, you told it at last class.
Yeah, I told in last period. Shall I erase it?
Yeah, ma'am.
Fine. Now see how we are able to convert haloarenes. We are able to convert amines into haloarenes. How? By Sandmeier's reaction. Right? So what is the Sandmeyer reaction that we should know first, right? When primary aromatic amine dissolve in a cold aqueous mineral acid. See what I said? When primary amine dissolve into cold, right? Aqueous mineral acid. Mineral acid what? HX. Right? It's treated with sodium nitrite. What we have to add further in that? Sodium nitrite. NaNO2. Correct? Yes. What you will get? You will get diazonium salt. You will get diazonium salt. And when this diazonium salt you have treated with cuprous halide. With what? Cuprous halide. Cuprous halide can be a cuprous chloride or bromide. Okay. So what you will get? You will get haloarenes. So this is a basic general reaction to understand the steps. Clear? What you have to take? Primary amine, you have to dissolve it into the cold mineral acid, that is HX, okay, and have to treat it with sodium nitrite. Sodium nitrite is NaNO2. If you don't know the name, you can write its name below. It is what? Sodium nitrite. Okay, you will get what over here? Diazonium salt. And when this diazonium salt you have treated with cuprous halide. Cuprous halide can be cuprous chloride or cuprous bromide. You will get haloarenes. Clear? Yes? Aditi, Chandana,
Yes, ma'am.
Yes, ma'am.
fine. So shall I erase it now? Shall I explain the mechanism?
Yeah.
Ma'am, 1 minute.
Yeah, please complete it. Once you have written, let me know so I can erase it. I'll let you know what happened exactly in a reaction first, and then we will look into the mechanism.
Remember how many classes like it's gonna take to complete this chapter?
Sorry, I'm not able to hear you. Wait a minute. Huh? Yes.
Ma'am, or how many classes is it gonna take to complete this chapter?
Still, I'm not able to hear you. How many?
How many more classes is it gonna take to complete the chapter?
Acha, this chapter is quite lengthy, beta, so it will take more time. Okay, rest chapters are not too much lengthy, but then this chapter is a lengthy enough, and it will take a time.
Ma'am, can you take a class in between, like to give a quick revision of electrochemistry, like I have a JEE test on next
Oh
Tuesday?
yeah, sure. Why not? Why not? I'll have a word with Manoj sir once regarding. If he permit me, definitely I'll conduct classes.
Like my test is on 23rd, so like I
And
wanna
what,
have
what,
a class
what
on
would be
that.
the chapter? What would be the chapter? Electrochemistry.
Yeah, only that chapter.
Okay, I'll try to finish it as earliest. If it won't finish, then too I'll conduct the class. If Aditi won't mind, I don't know both whether both of you are in the same college or different.
Yes, ma'am, you can wrap it off.
Okay, fine, no issues. So content would be what? JEE advanced or normal?
Like they still haven't given the info. Like they said, like it would be both advanced and mains. They haven't decided.
Okay, fine, no issues. I'll conduct the class. But then one thing I would like to ask both of you, whether you're understanding my teaching or not, because that's very important
Yeah,
for me.
ma'am. I'm understanding it.
Okay,
Yes, ma'am.
fine, thank you. Shall I erase it?
Yes, ma'am.
Fine. Now, what happened exactly in this reaction? Check first. This would be your benzene ring, correct? Right? And your primary amine, when it is directly attached to your benzene ring. What it is? Aniline, correct? What is this? Aniline. When it is treated with sodium nitrite with mineral acid, temperature would be cold. Already I said. So what would be the temperature? 273 to 278 Kelvin. So what would be the exact temperature, girls? 273 is nothing but 0 degree, correct? 278. 78 minus 73, how many?
5.
5. Right? 0 degrees Celsius to 5 degrees Celsius should be the temperature. Means this content should be too cold. Now, what happened? You will get the diazonium salt. What is the diazonium salt? In this, what happened? This nitrogen would be converting to N2 with positive charge, and your halide group would be attached with this. Salt, why? Because it has a positive and negative ion, and hence it is called as salt. Like in salt, NaCl, how it is Na plus and Cl minus, it is we called as a salt. In the same manner here also, we called it as a salt because it's a diazonium salt. We can say benzene diazonium halide. What is the name for this? Benzene diazonium halide. That halide can be either chlorine or bromine. Okay. Now this diazonium halide when we treated with cuprous halide, what happened? N2 plus X minus. When you are going to treat it with a cuprous halide would be what? Cu2 X2. This X2 can be either Cl2 or Br2. What you will get? Haloarene. At the place of that nitrogen diazonium salt, your X group would be attached. Okay. And your nitrogen group would be detached. And nitrogen would be released. Clear? This is the basic reaction. What exactly happened into diazodization? Okay. This is also called as what? Diazodization. Clear? Hello?
Yes, ma'am.
Fine. So basically, what is the process? Primary amine you have to take, correct? That primary amine, aromatic amine, you have to treat it with a cold mineral acid in the presence of sodium nitrite. You will get the diazonium halide, benzene diazonium halide, and when that you have treated with the cuprous halide, you will get a haloarene, and nitrogen would be released. So this is your basically reaction, and now we are going to see for the mechanism. If you have done with this, let me know so I can explain you the mechanism.
Yeah, I'm done.
Fine. Shall I erase it?
Yes, ma'am.
Fine. Now see what exactly happened in this. In the step first, you have your sodium nitrate group, right? That is Na, right? O attached with double bond with the nitrogen, and here it would be oxygen. So as this oxygen utilizes its lone pair to form a double bond with nitrogen, it become electron deficient. Okay, and here it won't be any double bond, or that would be charge shift onto the oxygen. So it is electron deficient and it is electron rich. Correct? Yes or no? NaNO2. What is this? NaNO2. This is the basic structure of NaNO2. Clear? When it would be treated with mineral acid HX, two molecules of the HX, what you will get? This electron rich species would be take two hydrogen from these two HX. It will form a water. Clear? And what else would be formed? This halogen will go with this sodium. It will form NaX, right? And you will get the triple bond over here. I'll let you know how. Na will go with X. This Na and this X will be formed NaX. This two hydrogen and this oxygen will be formed water molecule H2O. What else remain? Your O with positive charge, double bond nitrogen. But then as this gone, it has an electron over here. It is utilized to form triple bond, nitrogen oxygen triple bond. So you will get oxygen with positive charge, and here it will be triple bond, nitrogen oxygen triple bond. Clear? Yes?
Yes, ma'am.
Fine. Now, here how many halide groups? HX, how many mineral acid groups were? Two. So two hydrogen is utilized. One halogen goes with what? NaX. So one halogen would be remain as it is, and that would be released as what? X minus. Fine. Clear? This would be what your step first. This is what your step first in the Sandmeyer reaction. Right? Next would be what? Step second. In this, what we have to do? You have to take an aniline or primary aromatic amine, any primary aromatic amine. Okay. It has what? Nitrogen with two hydrogen as NH2 is there. Right? It has a lone pair. Nitrogen has what? Lone pair, correct? And your this N triple bond with oxygen positively charged would come over here. This nitrogen will give its electron to the, so this hydrogen will give its electron to nitrogen. this hydrogen will give its electron to nitrogen, and this lone pair would be attacked on this nitrogen, and that can be release the oxygen. Give me a while. Huh? Hello? Yeah, am
Yes,
I
ma'am.
audible? Yeah. So what happened? These two hydrogen and this oxygen would form a water molecule H2O, right? And you will get this compound. This benzene ring attached with what? Nitrogen, and this nitrogen would be attached with another nitrogen with triple bond. That is called as N2. Okay, this is what? N2 group. And this N2 would be positively charged. And as it is positively charged, your this halogen group would be come sit next to it. As we know that positive negative have a attraction among them, right? So this would be what? Diazonium salt. Right? Yes or no?
Yeah, ma'am.
Hello?
Yes,
Clear?
ma'am.
Yeah, ma'am.
Any confusion? Is there any confusion? Any part you have not understand? If it is so, let me know. I can explain it again.
No, ma'am.
No, ma'am. We already completed this
Fine.
lesson in
Shall I?
college.
Oh, you have already completed. So it would be really very easy for you. But then mechanism has
Half
been
of the
explained to you.
Ma'am,
Yeah? Yes?
you were saying something. I didn't hear you.
Hello? Yeah, I said like whether mechanism has been explained to you or not in your
Yeah,
class,
we
in
learned
your
it like
school.
this year also, and we learned it last year also in GOC and this alkanes,
And which
alkanes,
reaction was there for you
hydrocarbons.
last year?
I'm sorry?
Okay, fine, no issue. Sorry? Okay, I said okay, no issues.
Uh,
Fine. Now what you're gonna do? This would be your big diazonium salt now. Okay, that would be N2 with positive charge, and it would be attached to the X with a negative charge, and that would be attacked with what? Cuprous halide, Cu2X2, right? So it would be Cu attached with two halogens. Your X, here also X. Correct? Yes or no? So what happened in this case? This halogen would be released and it will be attacked here at the place of nitrogen. Nitrogen would get detached. You will get haloarenes. The X plus again Cu2, X and X, because the released X also goes with the copper and your catalyst would be regenerate. Understanding? Clear?
Yeah.
yes, ma'am.
Fine. So you will get haloarene by Sandmeyer's reaction. How you will get it? By Sandmeyer reaction. And what this reaction release? Nitrogen. N2 would be released in gas state. Clear?
Yes, ma'am.
Shall I erase it? Fine. Now, I have questions for you, which we have learned earlier on the basis of that. But then I just wanted to tell you about the replacement of iodine, like replacement of iodine from the diazonium salt. It won't require any sort of cuprous halide or cuprous iodide salt or cuprous iodide catalyst in that reaction, because as we know that it is highly reactive and it immediately by simply checking also reaction takes place. Means like diazonium salt would be converted into aryl iodide. Okay. Aromatic iodide you will get easily by just shaking the potassium iodide and the diazonium salt of benzene. Yeah, you need not to use any sort of cuprous halide in that reaction, and you will get the product directly that way. This is suppose your benzene ring, right? Diazonium salt would be N2 plus, your X minus, whatever it would be. If this you have just shake with potassium iodide, you will get iodobenzene plus N2, right? This is what iodo. Clear?
Yes, ma'am.
Fine. Now I have few questions. Let me see what difference you would say among these two. What would be the product form in this reactions and why? Major product only you should write. Huh? I don't want minor product. And why you have to tell me. Because this already I have explained. Major product in both cases. What happened? Aditi left out. Chandana, are you there?
Yes, ma'am.
Chandana, are you? Yeah. So what would be the product? And why? This is an addition reaction, right?
Yes.
Yeah, I'll give you what addition reaction, right? In addition reaction, what happened according to Markovnikov's rule? Markovnikov's rule, like your halogen would prefer to go at the more substituted carbon, right? Means it won't form a primary compound as a major product, it will form a secondary compound as a major product, correct? Yes or no? So you
Yes,
can
ma'am.
see this carbon is a primary carbon. Carbon is attached to two hydrogen, right? But then if you see about it, this carbon is attached to one aromatic ring. Here another carbon, okay, carbon-carbon double bond, and only one hydrogen is present here. And because of that, bromine would prefer to go, suppose this is your primary carbon, this is your secondary carbon. Bromine would prefer to go at the secondary position, correct? And hence your product would be what? The different color I'll show you. That would be easy to understand. This would be the benzene ring as it is. It won't affect at all, right? Here, hydrogen as it is. Then it will attach to the bromine. Carbon-carbon double bond will be break into the single bond, convert into single bond. Here is a hydrogen. Here is a hydrogen, and here also would be hydrogen. Correct? This would be your product. Correct? And it is due to what? Markovnikov's rule. Right? But then instead of directly addition of hydrogen bromide or any mineral halide acid. Okay. what we will get, if you use it with peroxide, if you use it with a peroxide, it won't follow Markovnikov's, it will form anti-Markovnikov. What? Anti-Markovnikov's rule. And anti-Markovnikov rule is also called as what? Sedzev rule. Okay? That you have learned into your grade 11th, right? And what you will get here as a product. This is your benzene. Sorry, it should be CH. CH2, C, double bond CH2. So double bond would be converted into single bond, correct? Right? Yes, Chandana? Yeah.
Yes.
Hello?
Yes,
Fine.
ma'am.
So double bond would be converted into single bond, correct? And now what happened? Hydrogen has it, right? So this HBr, hydrogen would go at this place, and your two hydrogen would be already present here, and they are preferred to go at the primary carbon. This is your primary carbon, this is the secondary carbon. Why this happened? Due to Sedzev's rule. And as Sedzev's rule has been followed due to presence of peroxide. Right? In Markovnikov's rule, what happened? Your halogen preferred to go at the more substituted carbon at the secondary position. And when you use a peroxide, it will go to the less carbon. If you will get the primary product as a better product. Right? And in Markovnikov's rule, you will get the more substituted product as a major product. So these things you need to keep it in your mind. Clear? Yes?
Yes, ma'am.
The basic difference in between Markovnikov rule and Sedzev rule. What is the difference? Peroxide, H2O2. Okay.
Okay, ma'am.
Time is up, right? I'm gonna end the class. I'll speak with the sir if it is possible to start with the electrochemistry. Definitely, I'll conduct you extra classes and I'll complete it. Okay. Fine.
Yeah,
Yes,
ma'am.
Aditi.
Yeah, ma'am. I just
If it
want
is
a
possible,
basic revision of
yeah,
that chart.
yeah, I'll have a fine. Now I'm gonna end class. Take care, students, till the time. Bye bye.
Bye, ma'am. Thank you.